wear strength of the gear tooth. Next example is wear strength of gear tooth. So now we are designing our gear on the basis of first we know that the beam strength, and then next second one is that wear strength of the gear tooth. So why we are designing on the wear? Because of it continually rotations. There having a pitting. Pitting means what? There's some scratches or that some of that material remove on the tooth of the teeth, so that we are designs the failure can occur in that wear as well as. So now we are considering that is the face or the tooth of the gear which have an assuming as a cantilever. So that why we are first upon design on the basis of that is the beam strains, okay, bending failure. So here we have an numericals one examples of wear strain. So a pair of spur gear with 20-degree full depth involute teeth consists of a 19 teeth pinion meshing with a 40 teeth gear. The pinion is mounted on a crankshaft of 7.5 kilowatt single cylinder diesel engine running at 1500 RPM. The driven shaft is connected to a two-stage compressor. Assume the service factor is 1.5. Here, the service factor will be given 1.5. The pinion as well as the gear is made of steel. So, the 40 CA. Here, the SUT is given 600 Newton per mm square. So, both the pinion and gear are that is the same material. The modules and the face width of the gears are 4 and 40 mm respectively. So first of all, using the velocity factor to account for the dynamic load, determine the factor of safety. So now in this here, in the previous we can find out the rated power. Now in this numericals, we are directly find out we are the factor of safety. And second one, the factor of safety is 2 for the pitting failure to find out the or recommended surface hardness for the gear. So now second one, so we are given the factor of safety 2 for the wear strength, and we can find out the brittle hardness number, surface hardness, that is BHL. Okay, let us see here. First of all, you can write down the given data that SUT for both the pinion as well as gears are the same. So now we are SUT 600 Newton per mm square. It will be a given, and power here 7.5, and speed of the pinion will be given 1500 RPM. Number of teeth on gear, the pinion is 19, and number of teeth on gear is 40. Module will be a given 4 mm. Face width will be a given 40 mm, and the service factor we are account for the using that is the velocity factors, which is the 1.5. First is, so we know that the factor of safety based on dynamic load by velocity factors. So we can calculate. So simply we are know that the formula of beam strength SB equal to MB sigma B into Y. M is module, B is the face weight, sigma B is bending stress of that particular material of pinion. Y is the Lewis form factor. Okay, so for 90, number of teeth on the pinion is 19. We are first calculate the Lewis form factor, and now we know that P effective is equal to CS divided by CV into PT. So now we can calculate the PT. So by using our, so the here directly given our power 7.5, and then we are taking, we can calculate the torque, that is the MT. Once if you know the MT, and you can calculate the PT. Okay, for the beam strength, since both the gears are made of the same material, the pinion is weaker than the gear. The Lewis form factor we can find out from the table 17.3. The pinion number of teeth on the pinion is 90, so that Y is equal to 0.314. From we are taken for the table 17.3, that is the Bhandari books already mentioned in that table. there are the one side number of teeth and other side Lewis form factor y, which will be a given. For the 19 teeth, we have that is Lewis form factor y is equal to 0.314. The permissible bending stress always we are taken one third of the ultimate tensile strength, that is 600 divided by 3, we are getting that is 200 Newton per mm square. So now therefore SB or beam strength equal to MB sigma B into Y. So we are putting SB module 4 face weight, that is the 40, sigma B 200 and Y 0.314. So we are getting that is beam strength sigma SB is equal to 10,048 newtons. Okay, so now we can calculate the tangential force due to the rotation torque. First of all, we can calculate the torque from that power. So that power will be given in the kilowatts. We know that formula of the power. So that is uh, P is equal to 2 pi mt divided by 60 into 10 raised to 3, or mt is equal to 60 into 10 raised to 6, which is directly power we are putting in the kilowatt, divided by 2 pi np. And then we are calculate the mt, that is the torque of the pinion, which is 47,746.48 Newton mm. So once if you are calculate the torque m, which is mt, so now we can calculate the pt. So that torque is nothing but we have, that is the force into that distance. Okay, that is we have the pitch circle diameters. So that is of our pinion. We can calculate by the formula number of teeth on that pinion into the module. So that is d dash p we are noted for the pitch circle diameter of the your pinion. So d dash p is equal to m into zp. So now it will be a comes 76 mm. So now we know that pt is equal to 2 mt divided by d dash p, or we are the formula mt is equal to that is d dash p divided by 2 into mt. Okay, so now we are calculate the pt, that is the tangential force on the gear tooth of the pinion. So that is 1256.49 newtons. Okay, so this is the our pt. So for we can calculate for the cv, that the velocity factor. So we are designed for the that velocity factor for the dynamic, so which are velocity is equal to pi d dash p np divided by 60 into 10 raised to 3. So now we can calculate the velocity, which will be coming 5.969 meter per second, which is less than that is our 10. So that why we are getting the formula cv is equal to 3 divided by 3 plus v. So there are the three formulas there. First upon, when the velocity is less than 10, we are considered cv is equal to 3 divided by 3 plus v, and the velocity is less than 20, then we are considered cv equal to 6 divided by 6 plus v, or if it is velocity is more than 20, so that the formula is cv equal to 5.6 divided by 5.6 plus square root of v. Okay, so now we are taken the cv equal to 3 divided by 3 plus v, so which is coming 0.3345. Okay, we know that the p effective is nothing but cs divided by cv into pt. Already we know the pt, and we are having this cs will be given in the numerical, and we are calculated the cv. So now pt we are calculated, pt will be a coming, which is the 5634.48 newtons. So now we know that SB bending stress, also sorry, we are called as the beam strength of gear SB is equal to factor of safety into P effective, or we know that factor of safety is equal to SB divided by P effective. We already calculated SB and P effective. SB is equal to 10,048 Newton divided by P effective. We are calculated 5,634.48 Newton. So that factor of safety, which is will coming 1.78. Okay. Now then the step second, they will be asking for the surface hardness for the gears, which are already given. The factor of safety is 2. So now we know that wear strength equal to P effective into factor of safety. Okay, already we are calculate the P effective and the factor of safety which will given to. So now wear strength we are calculated, which has putting the P effective 5634.48 and factor of safety will be given 2. So we are multiply by 2 and getting the wear strength. So that is 11,268.96 Newton. So now we have the formula for SW, or we call it as the wear strength, which is B Q D P K, where Q is wear formula, that is 2ZG divided by ZG plus ZP for the external gears. Okay, so that, and the K we are given that K is equal to 0.16 BHN divided by 100 whole bracket square. So now we can putting the value, already we are calculate the SWVR strength 11,268.96, which is equal to, so we are putting the B is equal to 40, Q we are calculated from this formula, Q equal to 2 ZG divided by ZG plus ZP. Here ZG is the number of teeth on gear and ZP is the number of teeth on pinion. So now Q is the, we are 1.356. Now we are putting the all these value. So we are getting the brittle hardness number, or we are called as the surface hardness, which is coming 413.35, or we are consider the around of 420, BHN equal to 420. Thank you.